matrix algebra and matrix fundamentals. So we'll talk about all the aspects here. This is how a typical matrix look like. So essentially a matrix is, when we take two matrices or multiple matrices, we call it as matrices. And this is nothing but simply an array of numbers. That is, if I write these numbers 23, 56, 92, and I just make a square bracket or a round bracket, we call this list or the arrangement of numbers. The arrangements of elements, items, this will be called as matrix. Or you can just say the matrix is nothing but a table. That is, table has rows and column. So matrix is simply a way to organize value into rows and columns. So these are the rows, 1, 2, 3, 4. These are the rows, the horizontal ones, and the vertical ones are called as the columns. So matrix is simply a way to organize values into rows and columns and represent these multiple values as a single structure. So let me tell you again, matrix is a collection of elements, items, values, which is arranged in rows and column. And the intersection of row and column is called a cell, and that cell will have a number. So this matrix have 2 rows and 3 columns. So we'll see various equations will be solved by this matrix, and it is represented simply by numbers. Boundary is, it can be round value, round bracket, it can be square bracket, it can either be straight lines. So this is the line, 2 rows, 2 column. The numbers are arranged like that. So why we use matrix? In mathematics, in computer science, especially the computer graphics, this matrix has an important role. Various combination, various computation can be easily done using matrix, and that is why matrix becomes so important for various sciences, especially the computer sciences. So this is matrices, if you see here, for 3D graphics. When we talk about matrix, what is the dimension of matrix? So if I say this is a matrix and I just ask you, what is the dimension of this particular matrix? You just have to tell the size in terms of rows and column. Just assume this matrix to be in a tabular form, and these are the rows and these are the columns. So just put 1, 3, -7 in the first row, 405 in the second row. For example, here you see there are 2 rows and how many columns? 1, 2, 3 columns. So the dimension of the matrix will be 2 cross 3. 2 cross, it is not 2 into 3. It will just tell you 2 into 3 is 6. 6 elements are there. Now you can have a matrix like this where you have just values in the column. This is called a column matrix. How many rows are there? 3 rows. But how many columns are there? Always we write a row into column. Number of rows into number of columns. So we have 3 rows, but column is 1. How many columns? 1. So 3 cross 1 is the dimension of the matrix. Here we have one more matrix, 160. Now here only 1 row is there. How many columns are there? 3 columns are there. So 160, 1 row and 3 columns. So 1 and 6 and 0, they are different members in 1 column, 1 row, but 3 columns. So when we write the dimension of this matrix, it will be 1 cross 3, and this is the dimension of matrix. The middle one is the column matrix, the last one is the row matrix. So what is the dimension of this last matrix, which is our row matrix? Is simply, first you have to write the row, that is only 1 row is there, and then you have to write the column, so into 3. So what are the notations and names for matrices? First, they are always written in the capital letter. A matrix can have square or curvy brackets. It can have the parallel lines also. For example, this one and this straight lines. So in either way you can represent a matrix. It depends totally on what notation you follow. So this is simply a matrix. If you have this kind of matrix, that is, we have 2 rows and 3 columns. In all, there are 2 into 3, that are 6 elements, 6 items, 6 values in this matrix. Here you see it's a special matrix because it has just one column. Since we have just one column, the rows can be any number. This is called as column matrix or column vector. Column matrix or column vector. Okay. So why we are calling it as vector? Because in mathematics, vector are also represented by this only. That is a single array of elements. So scalar is just a number, vector a number with the direction like the speed and the velocity difference. So here there is a third matrix. We just have one row and there are 3 columns. This kind of matrix are called as row matrix because it just have one row. Row vector or row matrix. Okay. So simply a matrix with one column is just called as a vector, and this is also a vector. This is the notation and names for the matrix. So what are the variables we use for matrix? Because matrix can be n by n. There can be m1 matrix, m2 matrix. There can be multiple number of matrix. Okay. So we have to use a variable to represent a whole matrix. You cannot write matrix again and again. For that, we use a capital bold letter. That is, this capital A is representing 1, 6, negative 3. If I have to square this matrix, I'll just write A square. If I divide this matrix by any other matrix or simply by itself, I will write A by A. So we represent this by capital letter matrix and then do the computation. For example, this matrix is showing, or this expression is showing, we have a matrix P, we have to square it, multiply it by T and multiply it by P and then equate it to C. All these are matrices P, T, C. Right? Scalar multiplication. In terms of normal computation, what we do? We just multiply values. For example, we have 3. So I want to do a scalar multiplication 3 with some k. For example, k is 2, 2 into 3 is 6. So we have enhanced or scaled this 3 2 times. So basically, this scalar multiplication corresponds to a scalar where there is a number which can scale the elements inside a matrix or a vector. Scale means it will increase, minimize or decrease. So constant or scalar multiplication of a matrix is simply a number. It can be any number, less than 1 or more than 1, it can be any number, multiplied by the inside. All the elements of the matrix will be multiplied by this scalar number k. That is lambda multiplied to every and each element. Let us take an example. If we have to multiply this matrix with a scalar 3, so what will be the result? 3 into 1, 3. 3, 4, 12. 3, 3 is 9. 3, 0, 0. 7, 3 is 21. 5, 3 is 15. So this is the constant or scalar multiplication. Now if we have a matrix A like this, 2A, I have to multiply it, or we have to scale it twice. We are basically scaling the matrix, increasing the content size. So all the values will be enhanced or increased by 2. So it will be 2Q, 2 and minus 8. 2 into minus 3 is minus 6. 2 into 1 is 2. 2 into 1 is 2. Right? This is the scalar multiplication. How about this? So you will see the addition also. Addition will always have the same matrix sizes. So just minus 3 and k. And now multiply this k with inside. So 2k into k is 2k square. 2k into k is 2k square. Okay. Now just add the corresponding element. That is negative 3 plus 2k square. So the final result will be minus 3 plus 2k square. And here k plus 2k square. That will be the final result. So ultimately we are multiplying each and every element with that scalar. Row matrices. Row matrices are those matrices that have just one row, only one row, or horizontal. Their elements are arranged horizontally. For example, you have this row 1, 2 and 3. These are 3 numbers here. This is called a row matrix, and these vertical ones are called columns. So how many rows are there? One row. How many columns are there? In this particular case, it is 3. But you can have any number of columns, but the row has to be only 1. And these kind of matrices are known as row matrices. Only one row. Columns can be innumerable. It depends on you. Column matrices. In column matrices, there has to be only one column. The numbers, values, items are arranged in just one column. So a matrices which has only one column is called, or they are called as column matrices. So this is one column. 1, 2, 3, these are values in one column. Rows can be any number. In this particular case, we have 3 rows and 1 column. When you have only one column, we call it as column matrices. So n cross 1 is the generalized way to represent a column matrix because it has one column. Square matrices. See, matrices we are talking about because there are multiple matrices that can be square matrices. So square matrices are those matrices or those any matrix which has a row and column similar, exactly same. So when the rows and the column, if they are same, the number of rows and number of columns are same. For example, if I write matrix like this, how many rows are there? 1, 2, 2 rows. How many columns? 1, 2. So you see 2 cross 2. So the row and columns are same. Row is equal to the column. So we call it as a square matrix. Here is also an example. We have 3 rows and 3 columns. 3 rows and 3 columns. So we call it as 3 by 3 square matrix. 1 by 1, 2 by 2, 3 by 3, 4 by 4, 10 by 10, 100 by 100. All these matrices are square matrices because the row and column numbers are same. Okay. So in various computation, we'll see it has to be square matrix depending upon, because I'll just write a matrix. See, 1, 2, 3, 5, 9, 8. How many rows are there? 2 rows. How many columns are there? 3 columns. So we have 2 rows and 3 columns. This is not a square matrix because the number of rows and number of columns, they are not same. So this is not a square matrix. Null matrices, or what is a null matrix? Any matrix where the elements are simply 0. All the elements or all the contents, all the values inside the matrix, if it is 0, then this is called as a null matrix. For example, if you have a matrix, just put all the values as 0. So all the zeros is just call it as a null matrix because this is a 3 by 3 matrix which I am showing you. So these are null matrix. Null means nothing, 0. Everywhere, every row and column, intersection cell will have only value as 0. Identity matrix. Identity is what? When you take a mirror and see yourself, it's your identity. That means you'll see yourself. Similarly, in mathematics, identity means what? Identity matrix is if you take any, say, value multiplied by this identity matrix, the value should come back. So a square matrix whose diagonal is 1, other element 0. The rows and columns have to be equal, then only you will get the diagonal. See, if I am writing 1, 1 at the diagonal, just assume it to be a square. The diagonal has 1, 1, other values are 0. So this kind of matrix are called as identity matrix. Okay. So we have, I am writing 1, 1, 1 here. I am writing a 3 by 3 matrix. Other values I just put 0. So I am just taking the diagonal, assuming it to be a square. So the diagonals are all 1, others are all 0. And this is called as an identity matrix. So this is a 3 cross 3 identity matrix. The previous one was 2 cross 2 identity matrix. Just one. This is a 1 by 1 identity matrix. So what we were discussing in identity matrix is, in mathematics, as I said, do we have any number, any corresponding equivalent in matrix algebra that if I multiply 3.8 with 1, we get 3.8. If I multiply 2 by 3 into 1, I get 2 by 3. If I multiply 5 by 1, we get 5. So the actual number comes back. Is there any equivalent, this kind of one equivalent in matrix? Yes, there it is. And that is called the identity matrix. That is, whichever matrix you multiply by this identity matrix, that matrix will come back. That will not be changed. There will be no change. For example, I'll explain you with an example. This A is our matrix, 2 by 2 matrix. And A into I we are doing. I we have taken as a matrix 2 by 2 with the diagonals as 1, others are 0. So I'm writing A here. Then I am multiplying this with the identity matrix. 1, 0, 0. Please remember the diagonals are 1, others are 0. So first row with second column, A into 1 plus B into 0. This is how we multiply matrix multiplication. And the first row with now with the second column. So A into 0, A into 0 plus B into 1, B into 1. Okay. Now again the second row with the first column, C into 1 plus D into 0. Then the second row with the second column, C into 0 plus D into 1. So all the zeros please eliminate. This 0 will go, this also goes, this also goes. A into 1 is A, B into 1 is B, C into 1 is C, and D into 1 is D. This is the same matrix, A matrix. So the value which is being multiplied with this A matrix, so that A matrix come back, is the identity matrix. So even if you do I into A, that same matrix will come. So I'm saying I is the identity matrix for A. So this is the identity matrix, and it multiplication of this matrix with any matrix, 2 by 2 matrix, in this case, will not have any effect. I'm trying to generalize the identity matrix. So if you are talking about n by n matrix, the n can be anything, 1000, 1 lakh, or any number. Just you have to do one thing. It has to be square matrix, and then the diagonal has to be 1. All the values in the diagonals should be 1. Other values should be 0. Okay. All diagonal 1, other 0. So it has to be a square matrix. This is the first condition. So this is the n by n matrix. A square n by n matrix has 1, that is 1 identity. But in case of a non-square matrix, if you have n cross m, then the things changes. It will have 2 identity matrix, 1 with the row and 1 corresponding to the column. Okay, I'm talking about only the square matrix here. So we have a matrix. This is a 3 by 3 matrix, and this is a 3 by 3 matrix, which is the identity matrix. So when you multiply these two, what you have done is 1, 1, 1 in the diagonal, and just multiply it with the whichever 3 by 3 matrix is there. This same matrix, A matrix, 1, 2, 3, 4, 5, 6, 7, 8, 9 will come back. See here, all the terms, if you add, it will be the same terms. That is why this IN or I subscript n is the identity matrix, right? Because it is I3 here, 3 by 3. 3 by 3 matrix, it comes back. Diagonal matrix. Diagonal matrix. So a square matrix is all of whose elements except those in the leading diagonals are 0. What I'm saying is, first it has to be a square matrix, and then all the elements which are not in the diagonal element are to be 0. Diagonal can be any number. It can be any number. Scalar matrix. Scalar matrix is a diagonal matrix, that is a square matrix with elements only in the diagonal, others are 0. But here the scalar matrix, the diagonal values should all be same. That is, if I am writing 2 by 2 matrix, the diagonal have the same value, 3, 3, 4, 4, 9, 9, any value, 3.8, 3.8. So the main diagonal value should be same, and there should be similar, others are to be 0. That is called as a scalar matrix. Triangular matrices. Triangular matrices. So a triangular matrix is that above the diagonal and below the diagonal the values are 0. Or you can say above the diagonal and below the diagonal the values are there. There are two kinds of triangular matrices: upper triangular and lower triangular. Let me start with the upper triangle. Please remember, everything is related to the diagonal. There will be elements in the diagonal. For example, I am making this 5, 9, 2, 3, 8, 4. Okay. So this is one triangle, and here I'm writing 0. So if you see this diagonal, upper diagonal or upper diagonal triangle, upper triangular is having values. That is why it is called as upper triangular. The below triangle which I'm making consists only of values which are 0. Okay. This is the upper triangular matrix. Now if I just change it, you can say flip it. That is, all the values in the below triangles are there. They have certain value, and the values which are above the diagonal are zeros. That is, let me make again a triangle. This is a below triangle I'm making, lower triangle I'm making. So since these lower triangle has values, this is called a lower triangular. The upper triangular has 0. That is why this is called as whichever triangle has value, that name is given. Upper triangular, lower triangle. Symmetric and skew matrix. Symmetric and skew matrix. Well, now for this we need to understand the transpose. So a symmetric matrix, a transpose is simply changing the rows to column or column to rows. So if I have a matrix A, and A transpose is simply we have converted rows into columns. So two things can happen. This A transpose can result in symmetric or skew symmetric. That is, if I transpose and if I get the same matrix, that is, if I take A matrix, transpose it, we get the same matrix. That is called the symmetric matrix. But if I transpose and I get the negative of the original matrix, that is negative of A, that is called as skew matrix. Skew matrix. Okay. So let us take this matrix, and I'm just changing the rows to the column. So let me make the matrix and demonstrate it to you. This is 1 0 0 0 1 0. This is just an identity matrix to make it simpler. Okay, this first row I have to make it as column. So 1 0 0 as column. Now second row as second column, 0 1 0. Third row as third column, 0 0 1. Now if you closely see, these two matrices are same. These two matrices are same. So A transpose is actually equal to A. So these kind of matrices are known as symmetric matrix. Now I'm taking second example. 0 negative 4 4 0 rows to column. So this first row 0 negative 4, I'm converting it to a column, 0 here minus 4 here. The second row 4 and 0, so I'm making it as a column, 4 0. Okay, now they are not similar. But if I take a negative outside, multiply every element with a negative 1, you get 0 negative 4 4 0. Now this was A and this is also A, but with a negative sign. So A transpose is actually equal to negative A, original matrix. A transpose, when it is equal to negative A, then it is called as skew matrix. Symmetric, A transpose equals A, skew, A transpose equal to negative A. Equal matrices. If two matrices, the order is same and the corresponding elements are same, we call them as equal matrix. That is, the dimension has to be same. One is 2 by 2, other has to be 2 by 2. One is 3 by 3, the second has to be 3 by 3. And each element, that is row and column, intersection cell, every element has to be, corresponding element has to be same. For example, A11 here, A12 here, A21 here, A22 here, the Aij form I'm writing. Here also I'm writing A11. So A11 is equal to A11, that is 2. A22 I'm taking 5 and 5, so A22 are same. That is, the corresponding values are same. For example, if I say I am writing a matrix A, B, C, D, and here I am putting certain values, and it has to be the same order. So 2.8, 3, 9, 5 by 6. So A will be equal to 2.8, C will be equal to 3, B will be equal to 9, D will be equal to 5 by 6, equal matrix, if they are equal matrix. Addition and subtraction of matrix. So the way we add two numbers, in matrix also, we add and subtract two matrices or multiple matrices. How do we do this? See, simply you have to add or subtract the corresponding element of two matrices. But the one thing you have to keep in your mind when you're doing this addition and subtraction, the dimensions needs to be same. That is, two matrix or multiple matrix which are being added or subtracted, the dimension should be same. When you add 2 and 3, when you add 2.3 and 6.2, you can also do 2 minus 3, you can also do 2 minus 2.3 minus 6.2. Same way, the matrix can also be added and subtraction. Only the situation is the dimension has to be same. Let us take a very simple example. We have a matrix A which is 2, 2, 2, 2. B is 1, 1, 1, 1. And when we try to add, we add the corresponding elements. First is that the both matrices are 2 by 2, 2 by 2, so that can be added. If one is 3 by 3, you cannot add it with 2 by 2. You cannot. So this 2, say corresponding elements we have to add. Let us see here. So 2 and 2, 1 and 2 and 1 will be added. You get 3. This 2 and 1 will be added. You get 3. This 2 and 1 will be added. You get 3. This 2 and 1 you add and you get 3. For addition, matrices are of the same size. They are commutative. That is, if you add A and B and then B and A, the result will be same. If you have three matrices A, B, C, A, B, C, the order you do, that is, first you add say A and B and add it with C, or first you add B and C and then you add it with A, the results will be same. This is called the associative property of addition matrix. What is the subtraction? Subtraction is again the subtraction of the corresponding element of two equal matrix, equal dimension matrix. But normally we don't subtract, we add the negative of other matrix. That is, we don't do A minus B, we do A plus minus B. So A minus B is nothing but A plus minus B. I'll just show you. So we have two matrices, A and B, same matrices. Now we have to subtract it. First we have to see whether the orders are same or not. The orders are same. Now we have to subtract them. So 2, 2, 2, 2. And then we have B. This is the A matrix. And then we have another matrix which is the B matrix. So when we add and then we negate the second matrix. That is, I multiplied -1 with all the internal elements, scalar -1 multiplication. Now you add 2 minus 1 is 1. 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 This is how subtraction takes place. Let us take a few more examples. First, you have to see what is the dimension. The order of this matrix is 2 by 3. The order is 2 by 3 here. So when you add, because this now can be added. Otherwise, the dimension are not same, we cannot add or subtract. The corresponding element. 1 and 6, you have to add 7. 3 and -2 will be 1. 3 minus 2 is 1. Minus 7 and 9, when you add, you get 2. 4 and 2, that is 6. 0 and 1, that is 1. 5 and 0, 5. Okay. Let us take one more example. So I'm just trying to show how we negate or we subtract. So this is a Q value, because why I have written this? Because I want to show that there will be solution of expression that can be done with these matrices. Let me write it 9 now, just to make it simpler. So what do? You don't do A minus B. You do A plus minus B. So you will do, first see the order. What is the order? It's 3 by 2, 3 rows and 2 columns. Here also 3 rows and 2 columns. Okay. Now the orders are same. Now we can either add or subtract. So first matrix remains unchanged, will be 3, -1, 0, 0, 2, 3. Now you multiply -1 with inside and make a plus. So multiplying -1 with each element inside, the sign will change and then you add, simply add. Okay. So 3 -9 is -6. 0 and 3 add, you get 3. -1 and -1 is -2. 2 and -1 is 1. 0 and 4 is 4. 3 and -1 is 2. So this is how you add and subtract matrices. Transposition. Transpose of a matrix is simply, matrix transpose is interchanging the row into columns or columns into row. This is transpose. It can be a symmetric matrix, it can be a skew matrix, or it can be some other matrix. So if I have a matrix, very simple matrix, this is called as a column matrix. It has element in the column. So when you convert this column into the row, 1 here, 2 here. So this is the transpose matrix. So B and raised to the power t. So what you have done, you have changed the column into row. Now you have a matrix like this, only one row is there and there are 3 columns. So this is called a row matrix. So how do we do? We just interchange row with column. So 3, 4, 9, I have made it as a column. So this is d raised power t. So we can represent it by transpose like this. So 3, 4, 9. This is how we do the transposition. So let us take a proper 3 by 3 matrix here, and all these squares which you see here are representing the rows. Now these corresponding squares will be converted to the columns 1, 2, 3. Now just see, 1, 2, 3 will be made as column, 5, 4, 1 I am making it as a column, 5, 4, 1, and 6, 7 row I am taking and putting it as a column. Okay, so this matrix is called as the transpose of A, transpose matrix. A transpose is like this. This is called transposition or transpose of matrix. So that can be two things. If you take A and take the transpose, if the same value comes back, that is called as symmetric matrix. When you transpose and you get a negative of A, then you call it as a skew matrix. Matrix multiplication. The way we multiply two elements. In matrix multiplication, we are multiplying two tables. So your matrix is what? It is just a tabular form. It's just a way to represent the values in rows and columns. So rows are horizontal, columns are vertical. So in matrix multiplication, the most important thing is the dimension. So we represent each element of a matrix like A, I, J. I represent the row and J represent the column. Okay. So when we do this matrix multiplication, the first thing is, what is the dimension of the first matrix? Second matrix, what is the dimension? So if you say this is an A matrix and call it that it has M cross N dimension, the second matrix is say K by L. What does it mean? Multiplication is possible only when this N is equal to K. When the column of the first matrix equals the row of the second matrix. N has to be equal to K, then only the matrix multiplication is possible. And the result will be having how many rows and columns? M into L, the row of the first matrix and the column of the second matrix. So there are 4 rows here. So what is the dimension? 4 and 3 columns. So 4 by 3 is the dimension. What is the dimension of the second matrix? It's 3 rows and 2 columns. So when you multiply, 3 and 3 are same because now the multiplication is possible. And the result will be, the dimension of the resultant matrix will be 4 by 2. Okay, 4 by 2. How do we actually visualize it? See, when you visualize it, same matrix I'm multiplying. What we do is, we take the first row and the first column. And you take corresponding values like A11 with B11 multiplied, write it here. Multiply A12 and B21. Write it here. Multiply A13 with B31, write it here. And then you add them. This is the first element that you will put in the resultant matrix. This term, okay. Now, remain to the first row and now you will increase the column. Now you go to the second column. So A11 into B12, write it here. A12 into B22, write it here. A13 into B32, write it here and add them. So when you add, this will be the second entry in the resultant. This is the entry here. Now you go to the second row. And now second row with the first column, second row with the first column and the second column. Third row, first column, second column. Fourth row, first column, second column. Now there are two matrices. How many rows and columns are there? It has 3 rows and 1 column. How many rows and columns are here? 2 rows and 3 columns. Matrix multiplication is possible or not? No, because the column of the first matrix is not equal to the row number of the second matrix. It is not possible. Now see the actual example of matrix multiplication. How do we do this? So first we have to see the dimension. That is, the column of the first matrix should be equal to the row of the second matrix. So how many rows and columns are there? 3 by 2. 3 by 3. 3 by 4. How many rows? 4 and 4. 4 by 2. Now the column of the first matrix is equal to the row of the second matrix. It is possible. Now what will be the result? The result will be 3 by 2 matrix. The first row and the second column. Okay. So what do? We start with the first row and the first column. 1 into 5. 0 into 1, write it here. 3 into 0, write it here. Negative 2 into 8, write it here. Now add them. So you get a value negative 11. This will be the first entry, negative 11. Right? Now, first row and second column. We have to complete first row with all the columns in the second matrix. So what do? I'll just do it. 1 into 1, write it here. 0 into 7, write it here. Then 3 into 3, 3 multiplied by 3, write it here. Negative 2 into negative 3, write it here. And just add them. When you add them, what will be the final value? The final value will be 16, it will be put here. Right? Now, when the first matrix is done, first row is done, come to the second column and again do it with second row, do it with all the columns of the second matrix. Okay? So when you 2 into 5, 8 into 1, 4 into 0, 3 into 8, when you multiply and add, you get 42. Now 2 into same second row with the second column now. 2 into 1, 8 into 7, 4 into 3, 3 into negative 3, that will be 61. Now coming to the third row and first column. It will be 7 into 5 plus negative 1 into 1 plus 0 into 0 plus 2 into 8 into 2, that will be 50. And then the 7 into 1, negative 1 into 7, 0 into 3, 2 into negative 3, and that gives you a value negative 6. Okay. Inverse of matrices. What is an inverse? If I take a value A and operate this with B and I get an identity element or identity, we say B is the inverse of A. So any matrix, say represented like this, the inverse, when inverse is applied to that matrix, that is you actually multiply them, you should get a matrix which is called as the identity matrix. Identity matrix. So A multiplied by A inverse should give you identity matrix, and this is the inverse of the matrix. So matrix A, it is non-singular. What is a singular matrix? The singular matrix is that value, the determinant should be 0. Non-singular, the determinant is not 0. So how do we write it? It is invertible. If we have an A matrix and a B matrix, when you multiply it, you will get an identity matrix of the same order. Same order. So this, I'll just show you what is happening here. 1 into 2 by 3 plus 1 into 1 by 3, this is the first element. 1 into negative 1 by 3 plus 1 into 1 by 3, this is the second element. Negative 1 into 2 by 3 and 2 into 1 by 3, add them. Negative 1 into negative 1 by 3, 2 into 1 by 3, add them. This is the element. So what do you get? 1, 0, 0, 1. This is the identity element. So this is the identity matrix of 2 by 2. So the inverse of 1, 1, negative 1, 2 is 2 by 3, negative 1 by 3, 1 by 3, 1 by 3. So the common notation of inverse is just A raised to the power minus 1. The inverse matrix A inverse is unique. That is, you will not have any other matrix that will be an inverse of a particular matrix. There will be only one inverse. So if you take the inverse of an inverse of an inverse, you get the original matrix back. Okay. And if A is an invertible matrix, then A transpose to the power minus 1, that is inverse of transpose, is simply equals to the A inverse transpose. That is the same thing. Okay. First you take inverse, then you take the transpose. Okay. This is all about this matrix algebra. Thank you so much. Take care of yourself.